Welcome to Operations with Radicals recap. In this video, we're going to go over adding, multiplying, subtracting, and dividing radicals. So our first example is subtraction, and think about what you notice about this problem. You might notice that the radicals are the same. Now there's the radical, and then the number underneath the radical is called the radicand. So when the radicands are the same, you can just subtract your coefficients. It kind of works like 5x minus 3x is 2x. It's the same concept. 5 minus 3 is 2. Keep the radical. Now in this addition problem, you might notice that the radicals are not the same, so we can't add them right away. Instead, what you have to do is simplify a radical. Now, radical 2 can't be simplified. However, radical 32 can. We're going to bring down the 3, keep it for later. The square root of 32 can be broken up into the square root of 16 times the square root of 2. Now what you don't want to do is choose 4 times 8 because 4 is not the largest perfect square. A good trick to think of is if your other radical is 2, well, the square root of 32 has to break up into 2 times something. 2 times what? 2 times 16. If you can actually add them together, that works. I'm going to keep on simplifying. I have 3 times the square root of 16 is 4 times the square root of 2. So altogether, when you're done simplifying, you get 12 radical 2. And now I'm going to bring down the actual original question. Now this looks like similar to the last example. Your radicands are the same, so you can add the coefficients and keep the radical. 8 plus 12 is 20. Square root of 2 is your answer. Now, keep in mind, if you have a different problem, let's make up a totally different problem. 3 radical 7 plus 4 radical 2. Neither of these can be simplified, right? And if they can't be simplified, or if you were to simplify them, and if you notice that the radicands are still not the same, then you can't do the problem, and it's already simplified. It's done. Nothing else can happen with it. So just keep that in mind. Let's try a multiplication example. Now, you can do these one of 2 ways, and the choice is really yours with what you want to do. The first way of doing it is writing everything under one big radical. So I can rewrite this as 3 times 12, all under the radical. From there, 3 times 12 is 36. And I know the square root of 36 is 6. The other way of doing this problem is by simplifying the radical first. Now 12 breaks up into the square root of 4 and the square root of 3. From there, the square root of 4 is 2, and then you have radical 3. We can rewrite this problem to be the square root of 3 times 2 radical 3. That turns into multiplying the coefficients first, and your coefficients are 1 and 2. So you get 2 radical 3 times 3, which is 2 radical 9. And then we know that the square root of 9 is 3. So you end up with 6. Clearly, this way is much more complicated than the first way. However, you can choose to do these however you wish. Let's talk about division. So when it comes to dividing, again, you can choose to do whatever you want. You might want to write this as one big fraction first. So you can have this as the square root of 36 divided by 4. Now we know that 36 divided by 4 is 9. So I'm going to write this as the square root of 9. And then the square root of 9 is 3. The other way of doing it is to simplify the radical up top and then simplify the radical on the bottom. And once you simplify, then divide. So if you did that here, square root of 36 is 6. Square root of 4 is 2. Well, 6 divided by 2 is 3. So you get the same exact answer. So to sum it up, when you are adding and subtracting radicals, it only works if the radicands, the numbers underneath the radicals, are the same. If they happen to be the same, then what you're going to do is keep the radical and add the coefficients or subtract them. If they're not the same, try to see if the radicals that are there can be simplified, and if they can be simplified, when you do the radicands now match, that way you can be able to do the problem. If you simplify and if you can't match the radicands still, then the problem can't be done. When you're multiplying and dividing, either multiply or divide first and then simplify your answer, or simplify your answer first, then multiply and divide, and then check to see if your final answer can be simplified in the end. And that's all for this video.